Identify the temperature change, delta T, of the mixture. The temperature of the reaction mixture increased from 20.0 degrees Celsius to 21.0 degrees Celsius. The change in temperature is calculated as delta T equals Tf, Ti equals 21.0 degrees Celsius. 20.0 degrees Celsius equals 1.0 degrees Celsius quad. Calculate the heat gained by the aqueous mixture. Q solution. Use the calorimetry formula relating heat transfer to temperature change. Q equals mc delta T quad. Substitute the total mass of the mixture, 100 G, the specific heat capacity, 4.2 J/G degrees C, and the temperature change, 1.0 degrees Celsius, into the formula. Q solution equals 100 G, 4.2 J/G degrees C, 1.0 degrees Celsius, equals 420 J equals 0.42 kilojoules quad. Relate the heat of the solution to the heat of the reaction, QRXN. Because the calorimeter is assumed to be perfectly insulated, the heat absorbed by the solution must equal the heat released by the chemical reaction. Since the temperature of the surroundings, the water, increased, the reaction is exothermic, meaning it released heat and has a negative enthalpy sign. QRXN equals Q solution equals minus 0.42 kilojoules. Determine the moles of reaction, NRXN, that occurred. The moles of both OGNO3 and NaCl can be computed using their volumes and molarity. Moles equals volume in L times molarity. Moles of OGNO3 is equal to 0.0500 liters times 0.100 molar equals 0.00500 moles quad. Moles of NaCl equals 0.0500 liters times 0.100 molar equals 0.00500 moles quad, because they react in a 1-to-1 stoichiometric ratio according to the balanced equation. They react completely without any excess reactant, meaning exactly 0.00500 moles of reaction occurred. Calculate the molar enthalpy of the precipitation reaction, delta HRXN. To find the enthalpy change per mole of reaction, divide the heat change of the reaction by the moles of reaction that occurred. Delta HRXN equals QRXN over NRXN equals minus 0.42 kilojoules over 0.00500 moles equals math. 84 kilojoules per mole of reaction quad. This confirms that option A is the correct answer. The correct answer is option A, minus 84 kilojoules per mole of reaction.